Thank you, everyone. Thank you for joining us for our second Green Biz Caledon workshop. We have a great session lined up with some great speakers today. So my name is Matt Burnett. I'm from Partners in Project Green. I'll be starting things off this morning and then providing a bit of an overview of our agenda before turning it over to our speakers today. So really glad that everyone can join us. I'll continue to let people in as they join. Just for housekeeping, going to ask that people remain on mute throughout the presentation today. If you do have questions, please do enter them in through the chat. You can, if you chat directly to everyone or to me as the TRCA host, we'll make sure that we capture those questions and ask them during our Q&A. So while we meet here on a virtual platform, I'd first like to acknowledge the importance of the lands that we each call home. We respectfully acknowledge that we are situated on the traditional territories and treaty lands, in particular those of the Mississaugas of the Credit First Nation, as well as the Anishinaabe of the Williams Treaty First Nations, the Huron-Wendat, the Haudenosaunee, and the Métis Nation. Land acknowledgement is a reflection on our relationship with the land and with the First Nations communities that live on the land. TRCA are stewards of the land and the water resources within the Greater Toronto Region, and we take that responsibility very seriously. We are aware that we are uniquely placed to restore and enhance this relationship. So when learning about the land acknowledgement, I've come to learn that it's really important to acknowledge your own personal relationship with the land as well. So for me personally, I grew up in Brampton and in Caledon in the Peel region. I've lived in Toronto and Niagara region as well for several years. I now reside in Orangeville, which is situated on the traditional territories and treaty lands of the Huron-Wendat, the Tun, the Mississaugas of the Credit First Nation, the Haudenosaunee, and the Anishinaabe. In thinking about today's event, I want to fully recognize the role that all Indigenous peoples play in passing down the knowledge of their ancestors to protect our environment. And I also want to express that my intentions today are to convene a platform for knowledge sharing and help bring people together to advance their sustainability goals as well. So on this slide, we just wanted to provide a couple of additional resources and links that we would really encourage people to check out to learn about their own relationships with the lands that they live on, work and play on as well, and reflect on your relationship with those lands. So thank you again for joining us today. We have a great session in store and really glad that you're here and that we're able to share it with you. Again, as mentioned at the top of the session, for a bit of housekeeping, I'd like to ask everyone to stay on mute. This session will be recorded, and through Zoom, you'll be able to chat with us directly and ask questions. So we'll be having a question and answer period at the end of the session. We'll be trying to save a lot of the questions that you have throughout the session for our speakers to address then, unless the speaker decides to ask a question to the audience or take a question earlier in the timeline. So before we get into the presentation, just wanted to also go over this agenda today. So I'll be starting things off with a bit of an intro to the Green Biz program before handing things off to Bruce Taylor from Enviro Stewards, who was at last week's workshop. So Bruce will provide a brief intro on our speakers, as well as some points sort of tying both of these first two workshops together. So our speakers today are Stephen Dixon and Gil Amdurski. Stephen will provide some practical guidance on energy management and how your organization, no matter how large or small, can find opportunities to improve efficiencies and make savings. Gil will then follow with an overview of low carbon transportation options, particularly electric vehicles, and looking at cost analysis versus combustion engines. So as mentioned, we'll conclude today's session with that Q&A. So now for a bit of an intro to Green Biz. Green Biz is a free program for businesses designed to help businesses of all sizes and sectors with the support they need to reduce their carbon footprint, green their operations, and save on their bottom line. This program was established in a partnership between the town of Caledon and Partners in Project Green over at the Toronto Region Conservation Authority. Green Biz Caledon will consist of a resource hub with a wide range of resources that will be continuously added and updated over the year. We'll also launch with a 4-part expert-led workshop series. So you're right in the middle of that today with part 2 of 4. And these workshops, as I'll mention on another slide, are really designed for helping to inform action. So as part of this partnership with the town of Caledon, Any Caledon-based business that is attending all 4 of our workshops will be eligible for our grand prize draw as well. So the workshop series is a major component of this program. These sessions are action-oriented, will help you with best practices and guidance that you can take and then utilize within your own facility. So whether you're a small restaurant or a retail location or an industrial facility, the information provided should be applicable in helping you find and act on opportunities within your own workplace. So the workshop series is composed of 4 parts, as you'll see here on this slide. We had our first session last week and are having our second session on energy management that represents sort of the first part of the workshop series. We'll then reconvene things after the summer months in the fall, looking at waste reduction opportunities, as well as employee engagement as well. And so a lot of these elements will come up throughout the series. There is a big component with employee engagement throughout, as is ultimately people that are helping to make the changes within our organizations and facilities. So please stay tuned for more information on those sessions. We'll be posting on social media and on our GreenBiz page on our PPG website with more registration information there as well. So the Resource Hub will be updated over the course of the year. It will be free to access and will officially launch within the next week or so with resources and materials from last week's session. The Hub will be frequently updated over the year with tools, guides, and videos that can really help your company improve on your environmental performance. So the goal is really to have these materials available so that you can use them as your own, incorporate them into your employee training, or your sustainability strategies, conducting internal water, energy, or waste audits. The resources are really to be action-oriented, and we're always looking for feedback from our participants in our workshop series for what kind of resources would help your business as well. So with the Resource Hub and the workshop series, our aim is really to help put sustainability into practice. Through free access to the materials available, businesses can build on their internal knowledge and capacity to identify opportunities for savings, all the while improving their environmental impacts. So this initiative also represents a great opportunity to network and collaborate with like-minded businesses, as well as learn about the available incentive programs. And so speaking of which, I just wanted to highlight a couple of different programs in the energy space across the GTA. So many of you might be familiar already with the Save on Energy programs for electricity upgrades and changing on equipment. Some of you might have already participated in Enbridge gas programs. I wanted to highlight them here again today to really emphasize the wide range of support that is available. A lot of that being in the form of financial incentives to help with upgrades or finding those efficiencies. So there is a lot of support out there and really do want to encourage businesses to take advantage of that as well. There's also some local programs that I wanted to highlight for those businesses that are located within the Caledon area. Different municipalities will have different programs as well, but here in Caledon, there are the financial improvement programs, as well as a great resource page on sustainable transportation. So hoping that everyone will keep these in mind as we get into our presentation today and go through some great content. So at this point, I will ask Bruce to come online just for a brief intro of our speakers.
Mm-hmm. Hey, thank you, Matthew. So excited to be here, and thank you for everybody who's come back. And although these workshops are being presented sequentially on different topics, try to keep in mind that they're all actually interrelated. So for example, last week was water, this week is energy. But if you save hot water, you've just saved thermal energy. If you save chilled water, you just saved electricity. If you reuse heat that you're getting rid of in a cooling tower, then you've saved water in addition to the heat and your greenhouse gas footprint. And so they're interrelated. And hopefully Stephen has a very compelling slide on kind of the engagement. So the last session is on employee engagement. He has an excellent slide. Hopefully he can at least speak to it on kind of technical changes alone, procedural, or together, kind of what the actual impact is of that engagement piece. And so the other aspect of, to keep in mind is just kind of the root cause based approach. So say when we get to the solid waste, we'll get into kind of solid waste auditing and where to send this waste, but always get back to why are we generating this waste in the first place? Why are we using this energy in the first place? What job is the water doing for us? Can we solve that same job differently? right? And so those two aspects, if you can keep them in mind throughout the presentation, kind of this root cause and this integrated systems where they're all kind of, if you change one system, it's going to impact the other ones. We have a great pleasure to introduce Stephen Dixon. On his bio, you can see there, he's been doing this for more than 40 years. We've been working together with him for half of that time and very excited. If you've watched Dollars to Cents workshops from NRCan, you may have been trained by him. You see the stats up there, 30,000 people is amazing impact on the next generation, right? A very compelling speaker. We've had him into our own office to do a primer on refrigeration systems, brought in a demo unit and whatnot. It was very exciting. And so very excited, wealth of experience, master's degree in system design, bachelor's of physics. He's in PEI, which is a very nice place to be. I visited him at his compound over there one time. And so very excited to introduce him. You can read the remainder of his bio on this thing there. And Gil, welcome Gil also. Gil has expertise in kind of renewable energy, sustainables, energy auditing, measurement verification, which is very, very important, right? So if you change something, if you don't measure and verify, it could have got worse, right? Unless you quantify it afterwards, right? And you can't get a rebate from anything if you don't know the before and after, right? And did it slip back? It was intended to be designed like this, but it actually get built like that or commissioned like that. And so that's a very valuable piece he'll like to get into. Gil has a degree in electromechanical engineering, photovoltaic training, postgrad in renewables, U of T, certified measurement and verification professional. He's going to be speaking on EV systems, electric vehicle charging. And excited to watch it myself because we're considering an EV for our own office in Elmira. Interestingly, we're going to put it next to our OV charging, which is OAT vehicles, because we have a stable there because we're in Elmira. And it's OAT vehicles where, I would like to see another session on that because I bet you it's even more sustainable because even afterwards, the manure is good for your garden and whatnot kind of thing. And so anyway, I'm excited to learn what I can from Gil's presentation. And I want to turn it back over to Matt.
Thanks, Bruce. So without further ado, Stephen, you can take it away, and really appreciate you coming on for that intro, Bruce.
Thanks very much for that introduction, Bruce. And I very much agree on that idea of the integration piece. For the 40 years I've been doing energy, what I realized is my background is in physics, which is like I'm really not a physicist, but that's what I went to school for. And that's sort of the fundamental science. But then I realized, and I did some work at Waterloo in system design engineering, where you bring it all together, the integration piece. And it's where energy moves from one element to the other in a system that often we lose some of that energy. Clearly, I've always said, Bruce, that energy follows water. We have to purchase it, we have to filter it, we have to treat it, we have to heat it, we have to cool it, and then we have to discharge it. So you're right, all the things that happen to water, and many of them are energy, absolutely. The other piece that I totally agree with you on is the root cause piece. Later on in my presentation, you'll hear me talk about waste, but I define waste as being energy we don't need to use. And the first question I always like to ask is, do we really need to use energy at all, as you said? So, maybe there's a different way to do something. I know in manufacturing, using compressed air for certain things is common, but it can be very wasteful. And maybe there's even a better way. We don't even have to use compressed air. So I definitely agree with those ideas, Bruce, in terms of how all this stuff integrates together. And overall, for my goal here today is that you walk away. I think you mentioned it before, what your goal was. But my goal here, my objective is you walk away, everybody online, saying, hey, I've got some new ideas and some new information. I'm excited. I might even provide you with some tools. I'm going to go away and do something. And if you go away and change the way your organizations use energy, then I've achieved my goal overall. So, all right, so let's jump into this one. We only have a little bit of time here this morning, and there's lots to cover. I'm going to start off talking about sort of the big picture. I call it energy management challenges and benefits, but I think it sort of sets the stage. And I will, Bruce, talk to that idea about the human aspect. Absolutely, I'm a huge believer in the human aspect. The reality is, though, we can do a lot, right? We can do a lot if we're willing to invest some money with some reasonable timelines for return investment. We can get a pretty substantial amount of savings. But we're seeing in many organizations today The slide says 10 to 20%, but I actually would suggest it's actually more than that through operational behavioral changes, things we can do without actually spending money. And for me, that's the foundation for the things that we have to spend the money on. So we could probably push well beyond the 30% piece if we're willing to spend money and we're willing to do the operational piece. And I'll speak to that one in a few minutes. There's no doubt that it goes well beyond technical. The challenge of doing energy management isn't just about using a new light switch or using a new light bulb or using a new compressor. It's really about how we use what we have. So I like to think of there being two types of actions we have to take, one which is operational, one which is technological. How we use the light switch, which light switch we use, right? Which light bulb we utilize and how we utilize it. So it really comes down to that integration of the technology with the human factor. And if we're talking about humans and people's behavior, awareness is going to be really the key to all of this. Habits, good habits which become procedures and feedback. Bruce, you talked about the monitoring and verification, measurement and verification. We do something, but how do we know 3 months, 6 months, 12 months from now that it's actually doing what we expect it to do? If we measure and we analyze that information, I'm not going to go into the details of that today. That could be a workshop on its own. But if we do that properly, ultimately, not only will we ensure that the things we've done stay in place, the things we've invested in are returning our investment, but we can discover more things. I'm going to show you a simple example of just taking some data before we finish here today and actually finding opportunities. And most of you will have access to this data relatively easily today because of the way the electricity system works. And ultimately then, any organization really has to embrace this energy, but the greater piece, the sustainability piece, from an organizational perspective. It isn't just one person's job. It's everyone's job. We all have something to contribute. We can all do something. And when we all work together and build that energy managing or that sustainability culture, wonderful things can happen. So to me, I truly believe this is where it's all at. And it's funny because years and years ago, I met a social anthropologist, and she said to me, Steve, you technical guys are never going to crack this energy nut until you deal with people. And ultimately, that's why today, every workshop I do begins with this slide here, the integration of people, technology, and the organization that pulls and glues us all together. It's not just about energy, right? It's not just about water. To me, it's all, there's many benefits that can come from improving the way we use both water, as Bruce talks about, but also the way we use energy. And I'd like to argue that if you find a way to improve comfort, productivity, safety, improve equipment reliability, you'll actually also find a way to save energy and reduce your impact on the environment. So I like to place those things that we derive from energy first, no compromise, but making sure that we're not doing it wastefully or inefficiently. And I often see pumping systems as an example that use energy inefficiently, and the energy that's used inefficiently not only costs you money, but it goes to actually destroy or damage the equipment, and that costs you money as well. And ultimately, it costs the environment. And at the end of the day, if we do this properly, right, if we focus on what we need to use energy for and find the best way, as Bruce talked about, to do those things that we need to do, it may not even involve energy, or it may use a lot less energy. We will find the best opportunities, and we certainly won't alienate people from the process, because if you deny people what they need, you're definitely going to alienate them. But if you enhance what they have, the best lighting retrofit I ever saw was a school where they improve the lighting in the gymnasium from an efficiency standpoint, 50% less energy. But the school principal called the maintenance department at the school board and said, thanks for painting the walls and cleaning the floor in the gym. It's much better than it's ever been. But they never touched the floors and the walls. It was because the lighting was better. They thanked them for having better lighting. And Bruce, this is the slide that you like. It's the one which talks about an organization, maybe not unlike many of the organizations online today, that had 4 different buildings in an area. So each one of the bars in this bar chart is one of their buildings. In their first 2 buildings, labeled technology, they implemented new technology. Read into that, more automation, building automation systems, controls. Well, one building was an absolute disaster, a 4% increase in energy. The second one was a mild savings, 3%, not what they were looking for. When they stood back from the whole thing and said, hey, let's think about the human aspect, because it was the humans that were defeating the technology from doing its job. By engaging people, creating awareness, providing feedback, working with people, 16%. And when the people in technology in the 4th building came together. So they engaged the people and engaged the technology, and people were able to work with it and made their job easier, but at the same time, they can enhance how the savings it would deliver, a 23% reduction. That's what I'm talking about. It's not one or the other. It's both together, right, in harmony and in synergy, so that we get more rather than less. All right. The other side of this whole thing, getting down to a very technical thing, and I've used this as a slide actually taken from PEI, and I actually started off working with many organizations in many parts of the country, but many small businesses in Prince Edward Island years ago, and we could create this slide for natural gas. It's interesting. We edited this deck, Matt. I forgot to take the number 2 oil out of here, because many of the businesses here use number 2 oil to heat themselves. But it doesn't really matter, because what this slide is about is something I want every one of you to do. And what we'll do, Matt, is we'll send people a spreadsheet where they can generate this own slide. You're going to put your electricity bills in. You're going to put your gas bills in. Maybe you've got some propane, whatever you have, you enter it in. And then you'll get this 3 pie charts, which basically represent the distribution of energy, cost, and carbon. And ultimately, what we want to be able to see is, what do we have to focus on to deal with cost? What do we have to focus on to deal with carbon? At the end of the day, it turns out that in most cases, and especially in a case where you're using natural gas, your electricity is your greater component of the cost. But certainly the natural gas that you would use would be a much, much greater component of the carbon. So it isn't just one or the other. You can't just do one or the other. You've got to do both, because as a business, you have to be viable financially, but you have to be sustainable, right? And one of the aspects of sustainability is your carbon footprint. So we have to focus on both energy and electricity and natural gas, or electricity and propane, or whatever fuel you're using to heat within your facility. So I'll provide a tool for that, Matt. We can send that out to everybody. You can put your numbers in and it'll generate your pie charts. And this slide alone, I've had many people go, wow, that really changed my perspective on things. All right. The next segment, I'm going to talk about a walkthrough. I'm going to talk about going through a facility. And this walkthrough was developed in small businesses like many of yours over many, many years of doing energy audits, energy assessments. I shy away from the term energy audit. I love energy assessment, energy walkthrough. But there are really 7 steps in a walkthrough you have to take. You've got to start with understanding your consumption, price, and cost. What are you using, and what's it costing you? And what impact, just like the last slide, is it having in terms of carbon? Then you need to understand how you compare to other organizations, right? Maybe you've got other facilities, there's stores, other plants, and so on within your organization. You can compare to theirs, or maybe you need to compare to others outside of your organization. I'll give you some ideas around how to do that. Then you need to know when your building uses its energy. And today, this is actually a very valuable and an easy way to do things. We can look at your electricity profile. Some of you are going to be big enough, you'll be able to get a gas profile hourly and have a look at that. We find many opportunities, right? And then ultimately, just having a basic appreciation of where it's all going. Is that machine over there, or is that system over there, or is this one in front of me, which is using more energy, right? And sometimes, the size of the systems physically can actually belie their actual energy consumption. So doing some basic numbers is a good thing. And again, I'll provide a spreadsheet where people can dial in some basic information about a piece of equipment, and it'll give them an idea of what that cost might be. Now, the first 4 steps is all about figuring out where all the energy is going. The next 3 steps is about what we can do. And first step is get rid of waste, right? And I define waste as being energy we don't need to use. So ultimately, the first step is what Bruce said, is do we really need to use energy at all, right? If we need to use energy, then are we using more than we need to use? Again, those are all the dimensions of waste, being things like time, volume, temperature, and so on. Even compressed air pressure is an element of waste. Do we need to have 100-pound air? Could we do what we want to do with 20-pound air? In some cases, you can't. So ultimately, it's about figuring out how to minimize what you're actually using. And then you want to maximize the efficiency, or improve the efficiency of converting the energy from the purchase form into the end use form that you need. Because waste takes place at the end use. Ultimately, what you've got to do is figure out how to get the energy from the purchase form into the end use form as efficiently as possible. That may come down to things like maintenance on filters. I know in my house, there's a simple little thing that I do every month, which is change a filter. It turns out that if I want to circulate air through the house all the time, or at least most of the time, with my fan on low speed circulate, if I have a clean filter, it's going to cost me 110 watts in my house, which is also my office. It costs me 350 watts with a dirty filter. Which would you choose? That's a huge difference for just changing a filter. So operational efficiency improvements come first, and then technological, where we look at, okay, is that the best fan? Is that the best boiler? Is that the best piece of lighting equipment, and so on, right? We can improve it by changing the equipment. And eventually, whatever energy we're using at that point, after we've got rid of the waste and improved the efficiency, then we want to think about where it's coming from, what we call the energy supply. And that's where things like renewables fit in. I didn't start with renewables, I finished with renewables. But ultimately, the path to either net zero energy, we've all heard the term, or net zero carbon, is going to come down to this. It's going to come down to understanding how you're using energy today, and then what you can do to reduce the consumption through waste and efficiency improvements, and then eventually substitute that renewable energy supply to get you to zero, one way or the other, right? So that's the 7 steps. We're going to walk through those because this is essentially an energy assessment. It can be a very technical assessment methodology, or it can be a very basic one that you take. So I'm going to encourage you to think about it from whatever point of view you're operating. So what are the 7 steps in more detail? We just talked about them. What we're going to do is walk through them now and just take a look at a few examples in each one. Understand the consumption and price and cost, right? So ultimately, and I distinguish between price and cost. Price is what you pay per unit. Cost is what you pay overall. And if you don't look in a detailed way at your electricity bill, and I've featured a Hydro One bill here. Many of you would have Hydro One. You know, there's many people online, so there could be many other utilities involved. But ultimately, most electricity bills today in Ontario have a demand and an energy component, a kilowatt or a kVA and a kilowatt hour component. And ultimately, if we just focus on the kilowatt hours and understanding our bills, as the gentleman in the picture here shows, you may come to the conclusion that your energy was up by 0.01%, but your cost went up by almost 2%. And you're exasperated because you don't understand it, but it's because you don't understand the demand side of it. And ultimately, it's not because you're paying $24 a kilowatt hour or more. It's because there's more than just the kilowatt hour element of the bill. So understanding the bill is very important. And you know, I took this directly from the Hydro One website. They do a really good job of laying out what that bill is. You know, I know a lot of utilities over the years may not have been seen as helpful in this energy business, but I really find they are. And ultimately, you know, having a look at what they have on their website, I'm going to feature another example of what's on a website from utility before I finish here today. There's a lot of powerful tools out there. So have a look at those tools. It'll really help you to understand your bill. Here's an example. Once a facility understood that they were paying for this demand thing, they realized that the air conditioning was being tested during a non-cooling season, and it turned out it was driving up their bill by 1%. So that's about 1% in this case was about $350 in 1 month. That's not a huge number. There's no energy savings attached to that, but ultimately, at the end of the day, it's a cost you don't have to pay. And it's as easy as looking at the bill sometimes to find those, tracking the bills. We'll provide a spreadsheet for you to do that as well, just like the one we have pictured here today. Because just putting those things in a graph can actually reveal trends and patterns that, hey, you go, what's going on here? And that's an opportunity. Compare yourself. Step 2, understand how you compare to others. Understand how do you compare to maybe other buildings that, you know, that are in your same business. Understanding how you compare to other buildings out there. There's a great tool for that. And I think, Matt, you're going to send along, if you haven't already, to folks access to the website for Portfolio Manager. It is an Energy Star tool coming from the States. But on the other hand, it's actually maintained and supported by NRCan, Natural Resources Canada, in this country. It's a great tool to allow you to compare both within a portfolio, if you've got 5 or 10 buildings, but also if you only have one building, to buildings out there across the country, and understand how you stand in terms of your energy intensity. What we often calculate is the kilowatt hours per square foot per year, or gigajoules per square meter per year. So it's a great way to compare one building to another and find out, well, maybe you want to find out your Energy Star score. If you're one of the select type of buildings you can do this for, you can actually get a score between 1 and 100, which represents where you stack up compared to other buildings. So at a building with an 86, a small office building here, well, actually, it's a large office building with 86. It means 14% of the buildings out there are better than them. It means 86% of the buildings are worse than them. So it kind of tells you where you rank overall. Here's another example. We took energy data for a small office building, and we did some simple calculations against benchmarks or comparators in a sense. And what we discovered was in this particular building, there electricity intensity, the arrow is pointing to in the wrong place in the slide, the electricity intensity actually happens to be 25% higher, right, than it would be at the benchmark. When we actually investigated, what we discovered, and this, we didn't do a walk through this building, all we did was looked at the energy intensity per square meter and the natural gas intensity per square meter per square foot. We looked at the demand intensity, realized the electricity was too high, realized that meant things were running too long, and we discovered there was an operations center that was causing the entire HVAC system to run 24/7. Huge opportunity, a very simple matter of actually adding a satellite, a small HVAC system for that small operation center, reduce electricity usage by 25%. That was huge, and it came just from the benchmark. So sometimes just comparing yourself to yourself or comparing yourself to a range of what's practical and normal for your building can find opportunities. All right, next step. Step 3 says, understand when a facility uses energy. And I'm going to actually focus a bit more in this one in the last segment that we wrap up with here today. But basically, this is a tool that I've used for the better part of 38 years. I've been in the energy business 41 years. And about 2 or 3 years in, I discovered that I could measure when a facility uses electricity. This becomes the electrical heartbeat of the facility. Now, do you get this off your electricity bill? No, but you can get this off. In many cases, you can sign on to my bill, my account with your utility, and I'll show you this later. And it'll actually allow you to look at this data yesterday, the day before, last month, even last year for that matter, and start to do some neat comparisons. You can actually see what you're using at night, which is basically, the lower part of this graph here. You can see how the building starts up, how the building shuts down. You can understand that this load over here is lighting, so this must be fans and computers and things like this in a small office building. So it's a very insightful type of graph. I'm going to show you more in this one before we finish here today. We have a specific section on using a profile to understand where opportunities exist in your facility. I'll tell you a story of a facility that did this. We've done this in many types of buildings. This is actually a municipal building. And we actually there was 2 buildings in this municipality. And the operators, we were looking at the graphs for the facilities, the purple one and the blue one. Turns out these buildings were very similar in size, but they were operated very differently. Although they were servicing the same population and the same user base, it turns out the one building and the building automation had a lot of things overridden on all the time. And that made the blue line a lot higher than the purple line. So 2 building operators, when we presented these graphs to them, they actually sat and discussed, and they found over $20,000 worth of cost-saving opportunities. And you can be guaranteed that there was a lot of energy, both gas and electricity, attached to that finding. Now, for them, that was a real win too, because they were able to actually see these things themselves. It wasn't somebody coming in saying, you should do this. It was the operator going, look what we found. And they owned that opportunity and they fixed it and they found those savings or realized the savings. All right. Understanding where a facility uses energy. This one becomes a little more complicated because you do have to do some calculation, but it's worthwhile sitting down if you can and starting to sort of understand which devices in your facility. You may need a little bit of help for this, all right? And there are probably some things that Matt and his organization can do to help you find some resources here. And there are people, definitely that can come in from the gas company who can help you to get some of these insights as well. So reach out to those. But at the end of the day, have a reasonable understanding of where all the energy is going in your facility, because that's going to form the basis for what you can do, right? And oftentimes, if you've got this particular breakdown here, people say, I didn't realize that the lighting, or I didn't realize the plug load. In this building, the plug load was 15%, but we found one the other day with the plug load, things you plug in the wall were 37% of their energy consumption. That was a thing that needed to take action on. All right, so let's take a little further walk down the road here. The last 3 steps: waste, efficiency, and supply. All right, I'm just looking at my timing here to make sure we're good here. So it always starts with what you need. And technically, we call this the current facility requirement. In fact, if you do what's called an existing building commissioning, which is where you take the systems in your building and you go through a systematic process of optimizing and really getting them working the way they need to be, you'll do that versus what's called the current facility requirement. What do we need? Do we need heating, cooling, air, fluid power, ventilation, illumination, all those things we get from energy? But to Bruce's point, do we really need? Maybe we could avoid using the lights. I had an office that I was in for the better part of 20 years. And I never changed the light bulbs in that office. Why? Because I had a window at either end, and I arranged my desks in that office in such a way that I virtually never had to use those light bulbs. The light bulbs lasted 20 years. That's both an environmental and an energy benefit. So again, can we use natural lighting? I know, it's a very simple thing, but you can eliminate a lot of energy use by simply taking advantage of the natural light that may be available in any facility. At the end of the day, you probably will need use of energy, but documenting what you need and not debating about it. A lot of times what we find is when it's not documented properly, it becomes up for debate, and nobody ever does anything about it. So making sure you understand specifically what you need is going to be very important, and whether you actually need to use energy at all. Getting rid of waste comes down to a number of key things. The first one is to, right-size the systems, making sure that you're meeting the need but not exceeding it. And very simply, turning things off, turning things down, and controlling things are really, things that fit into this category. All your control systems are really, they're technically advanced systems, building automation, things like that, but they're all about matching the requirement, making sure that you meet the need but not exceeding it. Turning things off, some things could be turned off. Sometimes it's manual. Sometimes we need to do automation, but sometimes we need to improve the elements of the building. I call, air leakage through a window. How do you turn that off? Well, you weather strip that window, right? Or you replace the window. Phantom loads, things that are left on and have the light on to say they're turned off, but they're really on. I've got an example in a video in a few minutes on that one. Turning things down, temperature, water, airflow, air pressure. Talked about air, compressed air. Some of you have some compressed air systems. Big opportunities in those systems. But it's not about necessarily putting a better compressor in. There's some good options for compressors. But at the end of the day, it's about understanding what you need and only using the energy that you really need to use. I remember one example in a metal stamping operation where they were using compressed air to move a part off the press after it was stamped. They were using the equivalent of about a 50 or 60 horsepower motor in order to do that, which was costing them about 40 kilowatts of electricity. Now, they came up with a better way to do it was by using electricity, but by using what's called a solenoid to shake the part, right? Doing the same thing that the air was doing. For that, it took about 1 kilowatt, the equivalent of less than a little over a horsepower. So that was like a 95% reduction just by saying, we don't need to use air. We can use something else. So to Bruce's point, always challenge the root cause. What do you really need to be using here? Is this the best way to do it? And it's not just, again, it's not just about going to the hardware store and buying a more efficient piece of equipment. It's about really thinking critically about how we're doing things. This example in the bottom right-hand side, I'm just going to blow it up on the slide so you can see it a bit bigger. This was a person in a hotel getting, whoops, can't see that one very well over that. This was a person in a hotel getting very creative. What he did was, because of the fact that the curtains, right, were blown by this unit ventilator into the room whenever, the air came out of them, it wasn't distributing the heating and cooling effectively, and it was annoying the people in the room. He built this little plastic shield, which allowed the air to move more effectively in the room, so getting more effective heating, cooling, and removing the annoyance of a window that was open or the light was coming in when somebody was trying to sleep. So, there's some examples of getting creative. Infiltration around a door. And then Bruce, you talked about things you can do with cooling towers. Absolutely. But I mean, there's just so many different ways, but we have to think creatively about how we do this and what all the integration opportunities are, meaning all the other things that can happen. Microwave ovens, right? Which uses more energy, cooking or the clocks. Well, it turns out that the clocks use more energy, right? In my microwave oven at home, it takes 14 watts to keep the clock and the thing waiting for me to cook something. If you multiply that by the number of hours in a year and do the math, it turns out that I have to cook food in my microwave oven, which is about 1,000-watt oven, for 20 minutes a day, every day of the year, to use the same amount of energy cooking as displaying time. So what do you do? Well, the problem is when you buy a new microwave, you're probably going to get a lower and lower over time. But bottom line, you can't change that. But it's a very interesting fact that a small amount of power all the time can amount to a lot of energy and be equivalent to a lot of power for a relatively short amount of time. So thinking about it. Some people unplug their microwaves, and sometimes people try to turn off the clocks. But at the end of the day, the newer microwaves will have less standby energy. So, but am I going to throw away my microwave? No, because that's got some impact on the environment as well. So I kind of have to balance things out. All right, parallel pumps. Maybe you got a couple of pumps and you're operating circulating water. This is a facility, an office building where this was happening. And it turns out that there were two pumps running. One of them was a backup pump. Didn't need to run. They even had fancy technology called variable speed drives that change the speed of them. And the variable speed drive in the first one told us exactly how much power it was using. So we could actually calculate if we could turn it off, what we would save. Almost $3,000 a year for simply turning it off. And that had a fancy piece of technology called a variable speed drive that was supposed to save energy. But because it was being overridden in the system to be on all the time, it wasn't. Compressed air leaks, huge one, right? In any facility, if you can deal with compressed air leaks, this is going to pay back extremely quickly, right? Most compressed air systems that we've looked at over the years have probably, you know, at least 10% of their capacity is going to hitting leaks. The worst we've seen is probably over 50%, but I would say 20 to 30% of most compressed air systems, if they haven't been looked at, the energy in them is going to overcoming leaks. That's just wasted energy. That's simple. Take a little walk through here, and we've got a few videos. I'm going to show you this one because it's a short one, but there's a few more that I'll highlight a little bit later, which I'm going to leave you to look at afterwards. This is actually from a restaurant. If you're a restaurant owner, but it's got some interesting facts in it. But this is how I would walk through a facility and look for opportunities.
A lot of restaurants have a lot of no-cost, low-cost opportunities. Let's take, for example, this TV over here. Looks like it's turned off, but it may be using power. I've got a little power meter hooked up over here. I'm gonna have a look at it. Look at that, 100 watts, and it's not doing anything. That's waste. Let's get this thing shut off. Next, we're gonna take a look at the windows. In the theme of low cost, no cost, I always like to check windows. Check the weather stripping, make sure there's no drafts. That way we're saving energy summer and winter, and we're creating a better environment for our customers. Thermostats, another great low cost, no cost opportunity. Making sure that we control temperature properly, set the temperatures up, set the temperatures back when we're not here, and making sure that we use the fan auto off switch in the auto position if we don't need the fan to run all the time. A great way to save electricity.
So I hope you enjoyed that little video. There's a couple more of them. And actually, if you go to the Save On Energy website, which you'll see there, there's a whole raft of these videos. These are 3 walkthrough videos that I did. It was kind of relevant to what we're doing today. There's a lot of other ones, short little videos about particular topics, interesting and very informative, and may lead you directly to some opportunities in your operation. All right, maximizing efficiency. That's where we basically take the energy we have to use and make sure we're converting it as efficiently as possible, that we don't lose anything in all those conversions. And to me, this begins with things like good maintenance, right? Keeping things lubricated, filters clean, making sure, you know, the equipment that transfer heat are clean and allow the heat to flow through it properly. If we have combustion equipment like boilers and heaters and things like that, making sure they're tuned up properly, making sure if we have things like compressors, fans, and pumps that we've looked at how they operate with respect to what we require of them. And we're using things like drives and we're using them properly, not leaving them on when they don't need to be on. And ultimately, then we've got the most efficient equipment that we can afford to put in there, right? And make sure when you're doing the business case for changing equipment that you don't just consider simple payback, how long you have to wait until you get the money back. I like to look at the return on investment. It turns out that replacing a dishwasher in a restaurant can actually be a very lucrative investment. Putting your money into the dishwasher, it comes back with an internal rate of return, which is more than comparable, way more than comparable with most other things you can invest in. So looking at efficiency as an investment is very, very critical. And we'll send along Matt a spreadsheet where people could actually do that. You know, what is my investment return calculation for a piece of equipment that saves some energy? Treating energy efficiency as an investment, I think, is very important. Here we've got an example, compressed air control system, right? You know, now we are talking about simple payback here, but ultimately this would probably have a return on investment of about 30 or 40% at the very least, right? How many other investments can you get 30 to 40% on for simply improving the way things are controlled? Maybe it's the rooftop unit, right? That's bringing air into your operation, that's circulating and that's providing heating and cooling, right? A lot of times these things aren't adjusted properly, aren't set up to operate properly, don't take advantage of free cooling properly. And without it, you could be probably paying, you know, 50% more for the cooling that you're getting in your building because you're going to refrigeration cooling, meaning mechanical cooling with compressors and that, earlier than you should, right? So making sure that those rooftop units are tuned up and operating in a very efficient state. Here's another video. If you've got a restaurant or any business that uses a lot of air for exhaust, and it could be manufacturing, various different businesses, but certainly restaurants, looking at HVAC systems and making sure they're balanced and meeting the needs. So I'm not going to play that video now, just in the theme of keeping on time, but definitely have a look at that one. This one's only about 2 minutes long. And if you've got a lot of refrigeration equipment, this is a busy picture, but ultimately, if you take a look around any kitchen in a restaurant, but many other pieces, you know, if you've got a food processing facility or you know, many facilities have refrigeration equipment. Take a look at what's out there and use this video to sort of identify some quick opportunities. Things like settings, things like keeping things clean, not allowing air to be obstructed or flowing around these machines. There's a lot of low cost, no cost opportunities, and there's probably also some opportunities for replacement with things like Energy Star devices as well. At the end of the day, there's really going to be two types of opportunities, as I said before: waste and efficiency, before we get to the supply side of things. But I always like to categorize the waste and efficiency opportunities into lower cost things we can do and higher cost things we got to pay for. The lower cost things you can do manually, turning things off, getting rid of waste, right? Or doing the maintenance properly, right? Making sure the operating conditions are where they should be. Ultimately, we may have to spend some money. But I always like to think about the lower cost things before I think about the higher cost things. So I kind of put an order here: 1, 2, 3, and 4. There's no doubt that 4 is always the fourth thing, but whether it's 2, 3, or 3, 2, manual control is the first priority, making sure that we're doing all that we can do through simple means. So the 7 steps ends with this idea of optimizing the energy supply. What fits into that category? Well, things like recovering heat. Many of our homes have heat recovery equipment. It might have a heat recovery ventilator. Many of you have an energy recovery ventilator, or you may have one of these things called a drain water heat recovery unit that uses the water going down the drain to heat the water coming back in. At the end of the day, this is the time to think about it. Once we've reduced the waste and improved the efficiency, then we can look at these types of things. Heat pumps are big today, really, really big, right? Everybody's looking at heat pumps from going from gas, right, from a sustainability viewpoint to electricity, heat pumps, air source and ground source heat pumps, and the renewable energy. So these are all fit into this category ultimately. And even people that are looking at supply contracts, I say, make sure you understand how you're using the energy before you sign a contract of any sort. So I always put supply contracts in this category. But it really, from the point of view of getting to net zero, the first 3 things on this list are really what we want to be thinking about in so many ways. And you know, I'm going to leave the thought with you that maybe there's a heat pump in your future. Whether you're replacing a rooftop unit and you can use a heat pump instead of just a traditional heating cooling unit with gas and electricity, or maybe it's an air source heat pump in the facility that you have a look. Ground source heat pumps work in the right situation. That's a bigger capital investment. And some of the heat pumps that are available today are incredibly efficient, or shouldn't really use the word efficiency, but they use a minimum amount of energy. Some of them can actually move heat around the building as well as taking heat from the outside air and bringing it in. So there's so many opportunities, and you're going to see lots of heat pumps in the future, and even ones that provide heat recovery for that matter. If you're having an energy assessment, and I would recommend you do your own walkthrough first, but then have an assessment done if that's something you feel you can afford. And I know that, Matt, you provide some resources for that type of thing. But I've kind of laid out the example of a hotel or a little motel that had an energy assessment. We'll send this along as well as an example of what you might want to ask for when you do an energy assessment. You know, so you get the breakdown of where the energy is going. You get the opportunities identified, but then you also get that nice table which shows you, if I do all these things, where am I going to end up, right? What are my CO2 emissions? What are my cost reductions? And what's my savings to investment ratio? And what's interesting here is this little hotel, you can see it over here on the right-hand side, the internal rate of return, the interest rate that the investment in these energy efficiency opportunities was worth than was 55%. Do you have a bank account or a mutual fund that can return 55%? Well, I don't, but energy efficiency does. So think about it from that point of view. As I said before, energy efficiency is an investment. Some simple worksheets here to help you moving forward. You know, taking action after an energy walkthrough, or even just take this worksheet and walk through your facility. Can I turn it off? 4 things to ask yourself. Can I turn it off, turn it down, or control it better? In the theme of the waste that I talked about earlier. Can I tune something up? Has it been looked at? Can I improve that the frequency of filter changes? Or maybe I need to get my HVAC guy to come in and take a look at that rooftop unit and really give it a good once over, a good tune up. You can tune up a whole building in a sense. I mean, in existing building commissioning, but you could probably take some of the larger systems and start to approach it that way too. Can I make something more routine? So maybe I need to change that filter, but maybe I need to put that on a checklist. There are many things that we can do on a routine basis that will contribute to more efficiency just through better maintenance and better conditions for the equipment. And eventually, maybe, can you make an investment in it? And there still are a lot of incentives and rebates available for doing this. So, maybe there's still some old lighting around there. Or maybe there's an old compressor on a piece of refrigeration equipment. There's so many things that you can do. It may need some money, but just remember, it's a good investment. Do the numbers and you'll realize just how good investment energy efficiency is. So last stage here, we've got about, according to my schedule, I've got about 6 or 7 minutes for this one to keep us on time. So one of the key tools that I talked about earlier for finding opportunities is looking at when your facility uses electricity. I'm going to tell you a little story here. This is a complicated looking graph, right? And it comes from a workshop, just like we're doing here today, but it was a face-to-face one that I did about 20 years ago. It was interesting because we were in a community center and we were talking about how you can use energy data to find opportunities in a facility. And there was there were 2 chaps in the room, and one of them put up his hand. He said, "Steve, can you tell us why our office building is using 50% more energy than the designers said it was supposed to use?" So they were told, this was a small office building in a community out in Western Canada, and they were told that the building was supposed to use 10 kilowatt hours per square foot per year. And that was pretty aggressive back then, right? There are not a lot of buildings today, even today in Ontario, that use 10 kilowatt hours per square foot per year purchase energy. They were using 15, right? And maybe some schools could get to 15, between 10 and 15, but most office buildings today are probably operating in the low 20 to 25 kilowatt hours per square foot per year. So that was a really aggressive target the designers had, and maybe they're just off base. Anyway, the chap said to me, "Steve, can you tell us how to get our building from 15 down to 10? And I said, "Well, I don't know anything about your building." He said, "Well, you've got this fancy machine that you can clip on and measure the electricity consumption." I said, "Yeah, we do." And I have my friend with me who's an electrician. He's qualified to install that. So we agreed at the break in the workshop to go to their building, which was about 3 buildings away from where we were in this little town, and install this equipment. So my friend Garth, he went over as an electrician. He installed the metering equipment, and what it did was meter how fast that building was using electricity on a minute by minute basis. This is the graph we got. Now, so I'm asking you to do that in your building? No, I'm going to show you in the next slide how you may be able to get data very similar to this from your utility, from their website for your building. There may be a meter on your building right now that can do this. And if it is, and you're not using that information, you're missing opportunities. So let me tell you a story about this one. So we installed it at around 10 o'clock on day 1. And then around 10 o'clock, just after 10 o'clock on day 2, my friend Garth went over and picked up the meter. So we had 24 hours of data in this meter. All right, and we scrambled to get it into a spreadsheet, and this is what we printed out. And there's 2 lines in this graph, and you really don't have to pay attention to the top line right now. The bottom line is the kilowatts. And if we take the kilowatts on the vertical axis and multiply by the hours in the horizontal axis, the area under this graph is the energy this building is consuming: electricity, energy, kilowatt hours. But the graph itself, what it's doing, it's kind of like the way a doctor reads an EKG. It tells me things about what's going on in this building. I knew that sort of the average load of the building was about 37 kilowatts during the day. I knew that the lowest this building got to was about 10 kilowatts at night, 10 or 12 kilowatts a night. That's a third. For a building with that aggressive energy consumption target, that was high, right? So that was the first clue that I had that there was something going on. And I started to look more closely at the profile. And we're able to identify, this arrow up here identifies that there is elevators. So these spikes are elevators. You don't see the spikes at night because the elevators aren't used at night. You see the spikes in the morning when the elevators are used. You can see the load diminishing. We call this the load, the kilowatt value diminishing gradually between about 4 o'clock and 6 o'clock at night. And I know from this line up here, which is called the power factor, that this has to be the lighting load. But I also know that as people leave a building, people turn things off incrementally. But then I know at some point the automation system at 6 o'clock At 8 o'clock, the automation system turns things off abruptly, right? So, and when that happens, the kilowatt value drops and this thing called the power factor goes up. That just confirms to me what's going on this line up here. So we know that the lighting is going off. We know some HVAC systems are going off. Then from about 8 o'clock to about 1 o'clock in the morning, I mean, things are diminishing. But what I see happening here is, when we walked through the building, we started to realize there was a lot of equipment being left on in this building. There was electric heaters, and I can tell there's electric heaters in here because of this thing called the power factor. They have very high power factors and electric heaters. This is a signature of electric heaters. When we got to the building late at night, we were able to, even before 2 o'clock in the morning, I didn't go through there at 2 o'clock. We went over there, I think around 8 or 9 o'clock at night. There was a lot of lights left on. There was a lot of computers left on. There was a lot of electric heaters under desks, right? And very quickly, we were able to account for that 5 kilowatt hours per square foot, that 50% more energy, simply by turning things off. The neat thing is you can see as the building starts up, I can even see when the fan comes on, the lights come on. So, in the right hands, these graphs are extremely powerful at finding opportunities. Now, so you're not like Stephen Garth. You don't have a power meter you can clip on. Maybe you do, but probably you don't, right? What do? Well, check with your local utility or distribution company, right? What we call the LDC or your utility. So you could be Hydro One. This is actually a graph from the Hydro One website. You go to the Hydro One website. I went there yesterday, pulled this graph off, right? This is our interval data portal. This is the portal which shows for a facility. This isn't a huge facility. It uses about 100 kilowatts, right? It's not a huge facility. It shows all the data I was talking about. It even allows you to overlay the temperature data on here as well. So you can get an idea of maybe the temperature is driving because of the air conditioning and cooling systems in the building. It allows you to, it was funny, I was looking at this one, Matt, because the example they brought here was on Simpson Road in Bolton. This is, now maybe it's a fictitious example, I don't know, but it's very relevant to your group here from Bolton. So this is actually comparing 2 different weeks and understanding why they're different. So there's a really powerful, if I can pardon the pun, tools to allow you to look at your electrical power or demand available from utilities. I know Orangeville Hydro have them, I know Electra have them, and definitely Hydro One has them. So make sure you take advantage of these things. Look at these graphs, see what they tell you. Is your night load, I mean, this night load here is pretty low. Look at this, 10 to 15 kilowatts, versus 60 to 70. That's actually very good. This one's not quite as good over here. Definitely a lot better than this building that was only a third. This one's turning down by probably 80 to 90%, right? So you can learn a lot from this data and you can find opportunities to simply turn things off, control things, but you can also use it to make sure, as Bruce said earlier, things aren't creeping back up again. So you might use it for a few days and do some stuff. Then you may wait a couple of weeks and do it again. Maybe you wait a month, but you look and you go, okay, we're still where we want to be. So it allows you to really keep an eye on what things are doing. Just like going to the doctor and getting that EKG to make sure you're in good shape overall. So on that basis, I'm a little over in time, but I think we started a little over. I'm going to leave you with a help desk for today's workshop. And that's a genuine offer to you that if you have a question, you want to know more, you'd like to know what I would do in a given situation, do I have a tool for something, do I have an idea around something, I'm more than happy to help you. I don't want you to hire me. I want you to go away and use this stuff. And if you need a bit of help to do it, send me an email, and I always love to help people. So over to you, Gil.
All right, thank you so much. Is there an in-between between you and I, Steve, or there you go.
Yeah, so Gil, yeah, over to you. Do you have the slides open or do you want me to share?
I'm going to try on my end just so that I can get my
Awesome.
my notes going. So give me 1 second.
Actually, just as Gil's getting ready there was a couple of questions. How are you comparing units of consumption in the pie chart, Caitlin? What I did, and you see it in the spreadsheet, but you take all the consumption, it could be kilowatt hours, could be cubic meters, and so on, and I resolve them all to a common energy unit. So one question, back to you there, Gil.
Yeah, no problem. Okay, am I on the right slide, the low carbon transportation?
Yep, all good.
You are,
Okay.
perfect,
And when I switch over, everything's working?
perfect.
Okay, great. So hello everyone, my name is Gil Amdurski. I'm a technical coordinator for the STEP program, which is the Sustainable Technologies Evaluation Program. We're out of the Toronto and Region Conservation Authority. We've been a group that's been interested in anything energy efficiency and policy related, mainly on the residential side. We're getting into a lot of the commercial side lately, the past 5 years or so. We're a nonprofit, highly collaborative body. This is one of our kind of main facilities here, the Archetype Sustainable House at the Courtright Center for Conservation, where we actually install pieces of equipment and monitor them and evaluate them for their performance. We also have a solar PV farm on site. We have some small wind, and we have lots of other renewable installations on site. Oh no, and this is going to automatically go through these slides, which I've had trouble before. Anyways, also throughout today, I mean, I only have 20 minutes or so, but please feel free to write some questions in the chat. Sorry, I missed the first couple of minutes. I had to take a kid to school, so I don't know what we're doing for questions, but I'm okay being interrupted, especially if it's on the topic that we're talking about on the slide. So Matt, if there's any way that you can help facilitate that, that would be great. So today we're going to talk a little bit about EVs, electric vehicles, and in a commercial context. We're going to talk a little bit about, commuter, class 1, if you will, vehicles, and then we'll get into a little bit of the heavier, medium, heavy-duty vehicles. So just a bit of context. I know we're talking about Caledon. So over 50% of Caledon's GHG emissions come from transportation alone. If you look at this chart, 2016 GHG emission inventory, you can see that about 54% actually comes from transportation. And the majority of that is actually commercial transportation. That's the dark blue there, the 29%. So there's really an impetus for us to be able to do something and put our decision-making bodies together to make the right choice in the transition. So one thing also that I like to point out when talking about EVs is that it's not just about climate change. There's lots of kind of non-energy and non-climate change benefits to making the switch to electric vehicles. So yeah, one of them here, you can see the chart there, or the figure there on the top. This was a report done by Ontario Public Health and some other consultants, and they basically looked at air quality as a public health indicator and how internal combustion engines contribute to air quality, public health, and public lives actually. So you can see actually here in this chart that some of the figures are quite staggering, something like almost 200 avoidable deaths per year within the GTA if we were able to get those internal combustion engines off of the roads. Another thing people don't think about is hydrocarbons, is the actual oils and crude oil that's transported around, right? I work for the TRCA, which is the Toronto Region Conservation Authority. One of the major things we do is we look at our watersheds. One of the things we do is watershed sampling, where we're actually evaluating the quality of the water within our rivers, lakes, and streams. And hydrocarbons is just a number that's just there. It's always, you know, it's been there for decades. It's maybe not always going to be there, but it's something that, you know, we have to worry about. It's in our water. It's in our environment. And then there's, of course, you know, bigger dangers like larger oil spills, which are catastrophic, of course. And then, yeah, not to keep beating you guys over the head with this, but again, the dangers of transporting fuels as well. So there's, of course, the very horrific Lac Megantic, I always say that wrong, I'm so sorry, disaster, which of course was a rail disaster back in 2013, a large derailment of a crude oil shipment, and right in the center of a town. And of course, 47 people lost their lives and countless others were impacted by that. There's also some other things that people don't think about in terms of internal combustion engines. This is another pretty awful story. In Alberta, in the space of about 1 month in 2018, 5 people in 2 different incidents inadvertently died of vehicle-related carbon monoxide poisoning while idling in their cars. So that's another thing to think about. It's carbon monoxide that's coming out of these vehicles. Anyways, sorry, I don't want to beat you guys over the head with this, but we shall continue. So talking about electric vehicles, talking about the current models that are today, you know, people's thoughts and imaginations about electric cars is that the upfront costs are just so high that they just can't seem to make the switch, and it just doesn't make sense to them. This image came out of a report that was done by Pembina, I believe. I'll link it afterwards. Basically showing side-by-side comparison of 2 sedan-ish vehicles. But you could see now with the cost of gasoline being so high, hovering around $2 a liter, the total cost of ownership is actually significantly less for the electric vehicle. You can see here that the gas vehicle is 48% more expensive to own over the lifetime of the vehicle, right? So here, the main factor is the gas prices. But even when gas was around, you know, 125, let's just say, these vehicles would have been almost on par in terms of total cost of ownership. You have a lot of benefits for electric vehicles versus internal combustion engines, is the maintenance and operation costs. So you're going to be doing way less brakes and rotors on an electric vehicle, because electric vehicles have regenerative braking, where they'll actually use the torque in the motor to slow down the vehicle instead of using the brakes. There's no transmission, there's no oil. So lots of benefits in terms of maintenance. And right now, I think that the biggest sell point is that gasoline is so expensive. I personally have an electric vehicle. It's a smaller range one, but it takes me on average, it's about 20 kilowatts per 100 kilometers. So probably about, you know, $3 or something like that per 100 kilometers of driving. I'm just going to pause here, see if anything has come in. So we talked a little bit about EV capital costs. So year after year, they are becoming cheaper, way cheaper. A lot of it has to do with battery technology and battery pricing. You can see here on the left side, you can see a year-over-year battery pricing, you can see how it's pretty much gone like 1/10 of the price that it was 10 years ago. And a lot of it has to do with competitive manufacturing. Tesla, obviously, one of the biggest leaders within the industry, but everybody else is trying to catch up, right? And trying to make vehicles that are attractive and that people will want to buy. Yeah, these vehicles have been around for a long time. I mentioned my Nissan Leaf, which is what I have. They started manufacturing that in 2010, right? So just to give you guys an idea, these have been around for a really long time. And right now, roughly, we're at about, in Canada, I believe we're at about 5% market share of EVs. But I can see that skyrocketing very soon. As a matter of fact, it's actually kind of hard to get yourself into an EV nowadays because there's actually wait lists and waiting periods. So I actually have this in another slide, plan ahead. So even if you're remotely interested in an EV now, take a look at what models there are and reach out to the dealerships or online dealerships and make your booking. There are reservation systems for some of these vehicles. But also don't forget the used EV market. There's a rather large used EV market out there. And actually you can get some incentives from organizations like Plug and Drive. Sorry, I don't have it in this slide, but I'll include it in the chat. So again, we're talking about benefits of electric vehicles. I'll try to speed through this and we'll get into some of those commercial vehicles that I mentioned. In Ontario, our emissions are actually very low, our electricity emissions. That's because we have an advantage of our electricity system. We have mostly nuclear, and say what you will on that. We have actually around 10% wind energy. We have about 30 to 40% hydroelectric water, Niagara Falls being one of the biggest ones, but we have them all over Ontario actually. So our electricity system is rather low in GHG emissions. So here in this kind of figure, you can see here some makes and models of popular vehicles and their emissions per kilometer. And you can see the staggering jump between, sorry, I'll have to explain the colors there. So BEV, that's battery electric vehicle. ICE is internal combustion engine. HEV, that's hybrid electric vehicle. And PHEV is a plug-in hybrid electric vehicle. So plug-in hybrids actually have a bit of a small battery bank as well as they are hybrid. And then we can compare that to something like Alberta. So the first figure we saw was Ontario, and the second one is Alberta, where their electricity system is much higher in GHG emissions than ours. So we can see how that makes actually a huge difference when we're talking about electric vehicles. One big question that everybody says, or everybody asks, maybe not everyone, is, what about the life cycle? What about the manufacturing of the cost? It's like, of the cars. Well, I've heard, and even my friends sometimes approach me and they say, oh yeah, but it takes more energy to manufacture those batteries than you'll ever recoup in savings or in GHG reduction, if you will. But we know that that's not the case, right? So here we're showing life cycle emissions of some very standard car types, so compact cars all the way to compact SUVs. And you can see that throughout the battery electric vehicles are actually much lower in life cycle emissions. Most of the emissions of the car, when we're talking about the whole life of it, are tailpipe emissions. Yes, there are emissions associated with the battery production of the vehicle, but people have to also remember there's GHG emissions associated with fuel production as well, fuel production and refining and moving fuel. So there's that aspect of it as well. How am I doing for time and questions? Anything?
No, you're doing great, Gil. We'll maybe make time for questions just around 9:50 or just after, depending on how many slides.
Okay, I'm going to try to go through this. So you're saying I have 5 minutes?
Yeah, five to 10 minutes, and we can take time for questions at that point.
Okay, great. Yeah. All right. So getting on to medium and heavy duty vehicles. So there are many of the typical large manufacturers that are currently entering this stream. A lot of small and some local manufacturers do actually exist and have been operating in this space for quite some time. Even now, there are a large variety of electric vehicles that exist in this space, medium and heavy duty electric vehicles that exist in this space. One thing I wanted to mention, although I have come to this nice, sexy looking Ford Transit here. Anyways, I wanted to mention forklifts. So if you guys have, some yards or commercial spaces, storage facilities, what may be that you're using forklifts, electric forklifts are a no-brainer. I haven't included it in this slide, but if you actually look at the market, the new forklift market, a majority of it now is electric. So that only kind of goes to show where the industry is going. And there's lots of benefits to making the switch from propane over to electric forklifts. So just keep that in mind, although I didn't include it in this slide. So medium duty vans, the delivery vehicles, kind of working vehicles. There's a lot that are in the market. There's some that are coming. So the Ford Transit, this e-Transit, is going to be available. I think most likely you're only going to be able to get your hands on it in 2023 sometime. But it has a pretty decent price range, considering the cost of the vehicle or the size of the vehicle and its battery bank. So yeah, it says 2022 Ford e-Transit. It's a fully electric powertrain, features single speed transmission and rear wheel drive electric motor powered by a 68 kilowatt hour lithium ion battery pack with a targeted range of 203 kilometers, with a price tag of about $65K. There are plenty of other vehicles, medium duty, these kind of delivery or urban delivery vehicles, if you will. On the right side, you can actually see a table of some available models. This has come from a study, again, by Pembina, specifically for Ontario. So there already are a number of vans from some local and some US manufacturers. And here's a case study, Perlator. They actually ordered some fully electric delivery trucks. They're the latest addition to the Canadian Courier's fleet of eco-friendly vehicles. Those ones, the fully electric ones, are serving the Vancouver area. They are built on the Ford F59 platform, and they're electrified by Motive Power. So this is kind of like an amalgamation of two companies that got together to build this vehicle. The powertrain, it provides 230 kilowatts of peak power, 308 horsepower, 2,400 pounds of torque, and 20% grid ability. So it's able to climb at a 20% grade. So Perlator's development of the technology marks Motive's first collaboration with a company in Canada. So Motive and Ford. So these kind of collaborations in these vehicles do exist, and we're going to start to see many more of them. Larger class vehicles. I know Caledon has a lot of shipping transportation and maybe shipping yards or yards that have semi-trailers. So one important vehicle to look at are the shunt trucks. They come in many names, including yard truck, yard holster, yard jockey, spotter truck, terminal tractor, shunt truck. Anyways, lots of names for these guys that can move trailers around. So they're used to move semi-trailers and shipping containers, loaded or empty. They're used usually for short distances, quickly and efficiently. They're commonly operated in warehouses, ports, cargo yards, truck terminals, cross dock facilities. They can be configured for both on-road and off-road applications. And so these vehicles are a perfect use case for battery electric vehicles. And they're a great way for fleets to sort of dip their toes into the commercial battery electric vehicle pool. They are able to have a reduced purchase price due to a much smaller battery. So most of these vehicles will actually have a very low daily mileage. And so the cost of this vehicle won't be so high because you don't need a massive battery bank in it. Here's a little bit of a case study. Boathouse Farms, this was in the United States. They bought 5 electric yard trucks, these shunt trucks. After a 2-year period, they evaluated it. It averaged 75% less downtime due to maintenance and 80% less in repair costs due to their internal combustion engine counterparts. So their counterparts, the diesel trucks, spent 522 hours in the shop, that is in repair shop, compared to 134 hours for the electric truck. The diesel model cost around $4 an hour to operate, compared to only 98 cents for the zero emission vehicle. The diesel cost to fuel their counterparts annually was about $16,000 versus the electric charging costs of only $1,600. So about 1/10 of the fuel costs of the operating costs. So other class vehicles, there are numerous, as I said before, medium to heavy duty vehicles already on the market. Lion, which is a Canadian manufacturer, E-Lightning, which is Canadian and US, International, Peterbilt. These are kind of larger, actually international companies. Peterbilt is North American, and these manufacturers have been developing their medium to heavy duty vehicles for quite some time now. I would say 5+ years. And just to give you an idea of some of the offering out there, there's E-Lightning, which again, they do have sales in Canada as well as the US. Just to let you know, their types of offerings that they have here. So kind of shuttle, cargo, delivery, food truck, and then kind of a straight-ish class 6 truck. There's Lion as well. Lion has, they have a class 6, a class 8, and then they have some other types of, refuse vehicles and multi-purpose vehicles, boom vehicles as well, just showing the one here as an example. Semi trucks. So this is if people were to try to imagine it maybe 5 years ago or so, they would think that it's totally sci-fi and totally undoable. But but it is, and it's happening. And there's actually vehicles right now that are being prototyped. There's vehicles right now that are actually even on the road and driving. There are many manufacturers that are getting into this game and already into this game. Freightliner is a large semi manufacturer. They already have their e-Cascadia, although I believe it'll probably be another couple of years until you can actually get one. Volvo, they currently have 6 models. That's internationally. There's probably only 1 or 2 available in North America. Daimler, their E2, and Mercedes as well. And of course, the one people always talk about, the Tesla, people, of course, always talking about Tesla. The Tesla Semi, if you haven't seen this thing, it is just crazy. It is nuts to actually see in real life. If you go to the YouTubes or any place you get your content and try to search up Tesla Semi, you could actually see it on the roads and being test driven in and around California, and it is totally cool. And the thing takes off like crazy. And they're actually really close to, I think, commercial production so far. I believe it's been prototypes, but they're probably going to be one of the first ones to mass produce these things. And here's some specs for you, just in case you're interested. Some pretty neat specs.
Yeah. No, Gil, I think this has been a great overview of all of the different types and classes of vehicles. We'll just have to put a pause there for now, just to make sure that we have some time for questions. I know there were a couple more slides, but we can get to that in the questions and make sure that everything's available for those on the workshop after. But I wanted to kick things off just by encouraging those that are on the call and can hang around with us for a couple minutes to please send in their questions. The first question that I had would be directed for Stephen. Just a lot of the stuff that you talked about today, Stephen, was fantastic and really applicable to businesses of different sizes and sectors. And so wondering, with kind of the thought of the smaller business in mind, what, and knowing that you have a lot of experience in those kind of facilities, what are some of the most common opportunities that you see in some of your walkthroughs? I know you alluded to some, but just kind of in wrap up, wondering if you could speak to that again.
Really depends on the kind of facility, but if you're looking at a restaurant, we often see just simple things like refrigeration maintenance, because that refrigeration equipment uses a lot of extra electricity when it's dusty and dirty underneath, not in where you store the food, but it's the part you can't see. That's the real action part. Filters, keeping filters clean, just control of devices, making sure things are turned off. I know it sounds boring. I mean, and my son once said to me years ago, he said, "Dad, do people really pay you to tell them to turn things off?" And I said, "Yeah, but it's a lot harder to get things turned off than it actually is to say that." And I realized that. But yeah, definitely those types of things. Improvements to the HVAC systems for sure. Like, you've got small rooftop units. There's a lot of good opportunities out there today to retrofit them, but also to make sure that they're operating properly now. Checking your automation. You may have automation, small or large businesses, even things like thermostats, checking the settings, making sure that they haven't been overridden. All those types of things are really, really important.
No, that's great. Thanks for that, Stephen. And just before I go to a question for Gil, one more for you, Stephen. In thinking about the Green Biz workshop series that we have, what are some things that you think would be helpful for the folks that are on the call? If there's one action that maybe they could do today, or one action they could do next week, or one thing that you think people can take and do before our next session when we all meet again in the fall of this year? What are some kind of activities that you really think are sort of achievable and really encourage people to take up?
Well, one thing that I talked about in the session was looking at your profiles of use. So if you can get hold of that profile of your electricity use, if you haven't seen it before, get it. My experience is there's always an opportunity to do something if you see that for the first time, for sure. And then filters. Go check your filters. Like, you got a lot of people sending me emails after the workshop. Hey, whether it be at home or at work, I checked the filters, and there was lots of opportunities there. If you're in manufacturing, I'd go out and check your compressed air system for leaks, right? Or have somebody come in and do a leak survey. There's some pretty simple ways to do that. So And I just to point out that I actually posted a couple of spreadsheets. I know there's a few questions around the pie charts. Well, the spreadsheet for creating it, I apologize. We had the wrong units. Like it was correct for where it was. Bruce answered the question properly. But if you want to create your own pie chart, and there's an example in there, and you can see where those come from, but also the financial analysis spreadsheets in there as well.
Great. Thank you, Stephen. And yes, as you mentioned, some of those resources you'll send along. I know you've sent some in the chat, but we'll make sure that we share them out with the audience today as well.
Yeah, there was a question from Jordan. I'm just going to say, Jordan, if you can just send me an email afterwards and we can converse. I have some thoughts on that for your new restaurant.
No, thank you, Stephen. And Gil, I know as part of your presentation, you were going to be mentioning some aspects of charging infrastructure, and I know that's top of mind for many people that are considering whether they're electrifying their fleet or even just purchasing a vehicle for their own commute. Can you speak to any of the incentives that might be available on the charging infrastructure side of things, or some I guess evolution in that regard? Oh, you're muted. Sorry, Gil.
Way too many things open. I do have a slide. I'd love to just bring it back up. Sorry, 1 second. Oh man. Yeah, there are incentives right now. Right now, TAF, actually, the Atmospheric Fund. I'll find the link and I'll post it. They're actually administering funds for Ontario and for the feds to distribute funding for charging stations. There is also funding directly from the feds. There's the IZEV program. Again, just trying to get this up here. Those are probably the main sources of funding right now. So I'm going to try to find those links and actually share them with you.
No, that would be fantastic. And I mean, as part of this program, we'll be sharing out a lot of information on where businesses can go for support. I know that, okay, great. Yeah. And then I'll just wrap things up after this because I know we're just over time.
Sure, yeah. Yeah, so here I have my notes about just funding just in general for EVs. This includes charging as well. Let me just find my notes. So there's the ZVIP program, like I mentioned, which is the NRCan, Natural Resources Canada, or federal program. They're offering, I believe it's up to 50% or even greater for EV charging facilities. Here we go. So they provide funding for traditional level 2 chargers and fast chargers with power up to outputs of 50 kilowatts or more. And contributes up to 50% of the total project cost, up to a maximum of $5 million per project. So those are for larger projects, the ZVIP, or you could go to TAF, the Atmospheric Fund, and I'll find that link to put it up there. But there's also other incentives for the vehicles alone. There's federal tax write-offs, accelerated investment incentives. There's another IZEV program, which, well, the IZEV is an incentive for the actual vehicle purchase price. That's the smaller commuter vehicles that I mentioned. And the biggest one, which was tabled in the 2022 budget, is the not yet released. There's a $550 million investment in an incentive scheme for medium and heavy duty vehicles. And that is coming.
Great. No, that's fantastic, Gil. And I know there's a couple of other service providers on the infrastructure fund as well in the GTA, and would encourage anyone that does have any questions, if they are considering moving forward with purchasing an EV, to definitely reach out to Gil and get in touch. We'll share his contact information as part of the presentation today in the slides. But I know we're just 5 minutes over, so really appreciate everybody who was able to stay online with us. Just want to give a big thank you to both of our speakers. It was a great, really informative presentation today, a great workshop to attend. Hope you found something useful, and hope you were able to learn a tangible action that you can now take away for your facility.